uh, permutations. In class 1, I have explained that what is a product rule, what is a addition rule, and how to find the number of arrangements of arranging some objects are taken all using a box method. Now, in this class, I'm going to explain how to find out arrangements of objects taken, some are all at a time using a simple formulas, or even without formulas also we can do. Here is a question. We can do this question without any formula. For a sports meet, a winner stand comprising 3 wooden blocks is in the following form. You can think like steps. Well, there are 6 different colors available to choose from, and each of 3 wooden blocks is to be painted such that no 2 of them has the same color. No 2 of them has the same color. How many different ways can the winner's stand be painted? Here see that no 2 steps have same color. Well, it is a very simple question. We have 6 colors. We have 6 colors, right? So here there are 6 colors. We want to color the steps such that no 2 steps have same color. So here is a process. You can think like boxes. This step can be colored in, can be colored in 6 ways. As we have initially 6 colors. Any one of these 6 colors we can use to paint the first step. Right. Okay, wooden block. Now, after coloring the first block, we have 5 more colors. We have 5 more colors. Well, now the second step can be colored in 5 ways. Right? This block can be colored in 5 ways, remaining 5. Remaining 5 colors. Now, first block colored in 6 ways, second block colored with the remaining 5 in 5 ways, and third block is left. This third block can be colored with remaining 4 colors, right? This can be painted or colored in 4 ways. So painting each block is a job or a piece of work. So there are 3 jobs. First job is done in 6 ways, second in 5 ways, third in 4 ways. All 3 together can be done in 6 into 5 into 4 ways. We are performing all 3 jobs one after another, right? This is the multiplication rule. So therefore, required number of ways equal to required number of ways equal to 6 into 5 into 4 equal to 120. Option A is true. This question came in CSAT 2018. 2018. In this way, you can do many number of questions using only a multiplication rule or using a box method. Now I will explain how to do a few questions very fast using a simple techniques or simple formulas. Here I am going to write what is the number of arrangements or permutations of n dissimilar objects taken or at a time. Taken or at a time. Or you can take all at a time also. So before I'm going to explain this concept or a formula, I'll explain with a simple example. Here is the question. The number of 4-digit even numbers that can be formed using 1, 2, 3, 4, and 5 is dash. Here, without repeating any digit more than once. No digit is being used. No digit is being used more than once. More than once. See, without any formulas, we can solve this question just by using the blocks or box system. We have a 5 digits. We want to form 4-digit even numbers. We can form 4-digit even numbers or 4-digit numbers or 4-digit odd numbers or 4-digit numbers divisible by 5 or 4-digit numbers divisible by 3. Any kind of question can be solved using a box method. So I want to find out a 4-digit number, 4-digit even number, sorry, 4-digit even number. So I would like to take 4 digits. There is no any, you can say like that essay writing. It is just a logical 1, 2, 3, and 4. Well, we want to find out 4-digit even numbers. So a number is an even number if its unit place is an even digit, either 0 or 2 or 4 or 6 or 8. Here you see we have that out of these numbers, we have 2 even numbers. Well, these are even and remaining are odd. These are even. So in the first box, you have to fill with even. This must be even. This must be even. So you can fill that first box with either 2 or 4, right? So there are 2 ways. There are 2 ways. First box can be filled in 2 ways. That is either 2 or 4. Well, no digit is being used more than once. So now there are only 4 digits left. Now coming to the second box. Well, this second box can be filled in. This second box can be filled in any one of those 4 digits. Now, two digits we have used. Now, 3 more digits are there. So this place can be filled in 3 ways, and this place can be filled in 2 ways. All right. There is no order of the boxes here. So you can write 2 into 3 into 4 or 4 into 3 into 2, anyway, no problem. So we have done 4 jobs one after another. So therefore, required ways equal to, it is 2 into 3 into 4 into 2. That's equal to 48. We have not used any formula. But instead of writing these individuals, we can create a simple formula. Suppose for the same question, the number of 4-digit numbers divisible by 5. The number of 4-digit numbers divisible by 5. Example 2. the number of four-digit numbers, the number of four-digit numbers, four-digit numbers divisible by 5, divisible by 5, using 1, 2, 3, 4, 5, using 1, 2, 3, 4, and 5, without repetition of digits, without repetition of digits. In the meanwhile, you can write without repetition of digits. It won't take more than a minute if you get the proper idea. The idea is just filling the boxes using the given digits by fulfilling the requirements. A number is divisible by 5 if its units place is either 0 or 5. A number is divisible by 5 if its units place is either 0 or 5. So now you see. Now question is very simple. Well, again I am taking 4 boxes because to form a 4-digit number. Well, we have only one 5. There is no 0. So you have to fix that first place is 5. First place is 5. Well, now we have to fill that remaining 3 places using remaining 4 digits. So this place can be filled in 4 ways using the remaining 4. This place can be filled in 3 ways with the remaining 3 digits, any one of this. And this is 2. Well, this is the answer. So now this process can be done using another simple method, that is, out of remaining 4 digits, we have to fill the 3 places that we can write as 4p3. This P represents a permutation. Permutation is nothing but an arrangement. So this is totally is nothing but 4p3 into 1. So what is meant by 4p3? You see, you start with 4 into 3 into 2. Product of 3 consecutive digits starts from 4. 5p2, 5 into 6. Product of 2 consecutive digits starting from 5. 10p4. 10p4 is nothing but 10 into 9 into 8 into 7. Well, I'm going to explain that what is this permutation. Like this, you can form the number of 4-digit numbers divisible by 4, divisible by 4. A number is divisible by 4 if the last 2-digit number is divisible by 4. Later on, I'll explain that example. Permutation. The number of arrangements of n dissimilar objects. N dissimilar objects means all are distinct. All are distinct. Taken or at a time. Taken or at a time. This arrangement in place of arrangement, they can give like a permutation also. So permute. Permute means just the order of objects is changed. The number of permutations of n dissimilar objects taken or at a time, is you start with n and decrease 1 by 1. N into n minus 1 into n minus 2 and so on up to n minus of r minus 1. This we write that NPR. This is n factorial by n minus r factorial. Here P stands for permutation. P stands for permutation. This P stands for permutation. Permutation. The proof of this concept is only one line. It is very simple. The proof of this concept. Well, how many objects do you want to permute? We want to permute R objects taken from n dissimilar objects. Then, so we want to permute R objects, so we have to consider R boxes. We have to consider R boxes. Consider R boxes. 1, 2, 3, and so on up to R times. So this is box 1, this is box 2, and box 3, and R2. Well, now it is very easy to fill the boxes, right? See, we have totally n dissimilar objects. Okay, so in the first box, you put any one of these n objects. So you can put in n base. Well, we do not repeat the objects. Now, there are n minus 1 objects after filling the first box. So now the second box has n minus 1 choices to fill it. N minus 1. 2 objects gone. Now there are n minus 2 objects. Fill the third box, n minus. Out of n minus 2 objects, you can put any one of these objects. At last, how to find what is the last number box, right? How to fill? See, here we have a 3. This is n minus 2. We are subtracting a number 1 less than the box number. We are subtracting a number from n 1 less than the box number. So here this is n minus 1 less than the box number. 1 less than box number, right? Like this. So filling up each box a job. Filling up each box is a job. So we are performing our jobs at a time, one after another. So we have to use the multiplication rule. So this is n into n minus 1 into n minus 2 and so on. N minus r minus 1. Of course, r minus 1 is in bracket. This is represented by NPR equal to n factorial by n minus r factorial. How? I will explain this. It won't take more than 2 minutes. Okay. The product of first n consecutive natural numbers is nothing but n factorial. See. Now, n into n minus 1 into n minus 2 and so on, n minus r plus 1. Expect what will be the next one. The next one will be n minus r. What will be the next one? N minus r minus 1. You go up to 1. So here I have multiplied a few numbers which comes after n minus r plus 1. So I should divide with those numbers. N minus r into n minus r minus 1 and so on up to 1. Well, this is nothing but this is equal to, we are starting from n and ending with the 1 without missing any digit in between them. So that numerator represents n factor. Here we are starting from n minus r and ending with 1. So this becomes n minus r factor. So this we represented by NPR. So from n dissimilar objects, if you are taking R objects and arranging, then it can be done in directly NPR without writing that box system. So it would be a little faster than filling up box individually. What happens if you take all objects at a time? All objects at a time. The number of arrangements of n dissimilar objects taken all at a time. The number of n dissimilar objects taken all at a time means we are taking all objects at a time and we are arranging along a line. Right? Here r equal to n. So we get that n, p, n. As we are choosing all, since r equal to n. This npn is nothing but n factorial. Npn is nothing but n factorial. I'll bring a few questions from CSAT how to use these formulas effectively. The number of four-letter words that can be formed using the letters of the word UPSC exam. UPSC exam word contains 1, 2, 3, 4, 5, 6, 7, 8 letters. So there are 8 letters in the word UPSC exam. You can think of that we have 8 objects. 1, 2, 3, 4, 5, 6, 7, 8. We want to frame 4-letter words, which means that out of these 8 objects, we have to select 4 objects and arrange them. In another way, what is the number of permutations of 8 objects taken 4 at a time? Taken 4 at a time. So answer is very simple that the answer is out of 8 objects, we have to select 4 objects and arrange them. That is 8p4. So the number of 4-letter words that can be formed using the letters of the word UPSC exam means there are 8 objects. We have to frame 4-letter permutations. The number of permutations of n dissimilar objects taken r at a time, is NPR. Similarly, the number of permutations of 8 different letters taken 4 at a time, is 8p4. So we can calculate this value 8 into 7 into 6 into 5. I don't simplify this. Or you can think of this question using filling of box. Filling up how many boxes? 4 boxes. We want to fill 4 boxes because we want to frame 4-letter words. All right. There are 4 boxes. First box can be filled in 8 ways. Assume either from left to right or right to left. This place can be filled in 8 ways as there are 8 letters in the UPS exam. Next, second box, 7 ways. Third box, 6 ways. And last box, 5 ways. We got the same answer. So instead of writing this, immediately you can write 8P4 as we are selecting 4 letters out of 8 letters and arranging. Now, how many of these 4-letter words begin with vowel, and end with vowel? Means first letter must be vowel and second and last letter also must be vowel. Now let us see how many vowels are there in the UPSC exam. There are 3 vowels and 5 consonants. Well, there are 3 vowels, U, E, A. There are 3 vowels. Now I will use again the box method. The box method is a very powerful tool to solve permutation problems effectively. 4 boxes, 1, 2, 3, 4. We want to fill the first box and fourth box with vowels only. Well, see the first and last. This must be vowel, and this also must be vowel. Well, we have 3 vowels. Well, so we can fill these 2 boxes with 3 vowels is nothing but 3P2. 3P2. Or you can think of that this box can be filled in 3 ways and 2 more vowels left. So the last box can be filled in 2 ways. Now we have to fill the remaining 2 middle places with the remaining letters. After filling first and last with vowels, there are 6 letters. So these 2 places can be filled in 6P2 ways. So therefore, answer is filling of each box is a job. So answer is 6P2 into 3P2. How many of these 4-letter words neither begin with vowel nor end with vowel? The first question is begin with vowel and end with vowel, whereas the second question is neither begin with vowel nor end with vowel. Well, the number of 4-letter words from the letters of the word UPS exam, which are neither begin with vowel nor end with vowel. Means beginning letter should not be vowel and ending letter also should not be vowel. Which implies that first and last letter of 4-letter words must be consonants. So this position must be consonant. This is a consonant. And this also must be consonant. First and last. Out of 8 letters, we have 3 vowels and 5 consonants. So let us fill these 2 boxes with 5 consonants. So we can fill these 2 boxes with 5 consonants in 5P2. Or you can say first box can be filled in 5 ways, last box can be filled in 4 ways using 5 consonants. Now two boxes have filled with two consonants. So now we have to fill the remaining middle two boxes with the remaining 6 letters. So these two boxes can be filled in 6P2. First box is filled with consonant. Second box is filled with consonant. And now two middle boxes can be filled with either vowel or consonant. Because these two boxes have no restriction. Only first letter should not be vowel and the last letter should not be vowel. So therefore, required number of ways equal to 5P2 into 6P2. 5P2 is nothing but 5 into 4, 20, 6 into 5. So this is equal to 600. Once again, I am explaining that first letter should not be vowel, last letter should not be vowel. So which means that first and last must be filled by consonants. As we have 5 consonants, so the first and last box can be filled in 5P2 ways. And the middle two boxes with the remaining 6 letters can be filled in 6P2 ways. If you are getting confusion, you can fill individual box. First box in 5 ways, last box in 4 ways. There are 6 letters left. So now the second box can be filled in 6 ways and the third box can be filled in 5 ways. There is another question important for UPSC exam. The number of 4-letter words that can be formed using the letters of the word UPSC exam such that all vowels come together. This is important. All vowels come together. Right? So all vowels come together means U, A, E. These 3 letters, whenever you are arranging 4-letter words, these 3 letters should come together. These 3 letters should come together. So you take this. So consider all these 3 letters as single object. So whichever objects we want come together, those all considered as a single object. Here we want that all vowels come together. So consider that all vowels as a single object. U, A, E. Of course, here order is important. It is like when parents along with children going to a movie, they all want to sit together. They all want to sit together. Right. Of course, we can arrange internally among themselves, but at any cost, they all must sit together. So here U, A, E, these all 3 letters together can be considered as a single object. Now P, S, C, X, M. These are the remaining 5 vowels. Well, so totally we have 6 objects. These are the 5 and these 3 are 1. These are the 6 objects. All right, you see, we want that all vowels come together. Sorry, this question is wrong. I'm discarding this question. The way of asking question is entirely different. So sorry for the first question. The third question is I have interpreted in wrong way. Now the correct question is, in how many ways the letters of the word UPSC exam can be arranged such that all the vowels come together. All the vowels come together. Right. Now the method is very simple. There are many questions based on this concept. We want that while arranging the UPSC exam, we want that all vowels should come together. They all come at one place. Well, so here we have three vowels U, E, A. So we consider that these all three vowels as a single object. U, A, and E. These are all considered as a single object. Single object. Suppose if we want four objects come together, you consider those four objects as a single object, comma. And what are the remaining objects? The remaining objects are P, S, C, X, and M. So now we have totally six objects. We have totally six objects. If we consider that UAE is packed, it is totally packed up. It is a one box. Right. Now these six objects can be arranged in. These six objects can be arranged in. We are taking all these six because we want to arrange all the letters of the word. In how many ways? All the letters of the word. In how many ways? All the letters of the word. These six objects can be arranged in. These six objects can be arranged in six factorial ways. We are taking total objects. Six factorial ways. For example, like this. I'll give you an example. Now, answer is not yet finished. Like this. U, A, E, right? They all come together. S, P, C, M, X. This is a one possible arrangement. One possible arrangement. Now you see that among U, A, E, internal arrangement will be there. Right? These three letters, U, A, E, among themselves can be arranged in UAE. Among themselves can be arranged. We have a three letters and three places, so we can arrange them in three factorial ways. Out of n objects, when you are taking all the objects, the number of arrangements is n factorial. So job 1, arrangement of six objects. Job 2 is arrangement among the UAE, internal arrangement. So therefore, the number of required ways is equal to, the first job is 6 factorial, whereas the second job is 3 factorial. So whenever we want to find the arrangements of some objects in which particular objects always come together, we take those particular objects as a single object and mix with the remaining objects and then arrange them and then multiply with the internal arrangement of those objects come together. Now, here the question is, all vowels come together. There is another question that no two vowels come together. No two vowels come together. No two vowels come together. Out of three vowels, no two vowels come together in the arrangement. Means all three vowels must be separated Or you can say that there must be at least one consonant between every pair of vowels. There must be at least one consonant between every pair of vowels. Sorry, consonants. Now here, no two vowels come together. No two vowels come together. Means all the vowels must be separated. So what is the process? Here the process is process, right? Exclude vowels and arrange the remaining objects. Right? So exclude restricted objects. Exclude restricted objects. Exclude restricted objects. Restricted objects. And arrange the non-restricted objects. And arrange the non-restricted objects. Okay. Here, what are the restricted objects? Vowels. What are the non-restricted objects? Consonants. So let us arrange consonants. The consonants are P, all right, S, C, X, okay. I'll write that X as like this. And then yeah. Here one into I wrote, here one into I wrote. This is known as a gap. That gap I have represented by into mark. This represents a gap. Gap between two objects. Gap is represented by into mark. All right, you see that these five objects, there are five objects. These five objects can be arranged in 5 factorial ways. Right? So non-restricted arrangement, non-restricted objects can be arranged in 5 factorial ways. Suppose if you want to arrange girls and boys so that no two girls sit together, then arrange the boys. Suppose we want to arrange 5 girls, 5 boys so that no two boys sit together, then arrange the girls. So here that consonants P, S, C, X, M can be arranged in 5 factorial ways. This is arrangement of consonants. Arrangement of consonants. Non-restricted objects. Arrangement of consonants. Or you can say the number of ways of arranging 5 consonants. Now, how many gaps are there? How many gaps are there? There are 6 gaps. There are 6 gaps. Well, this is a gap 1. This is a gap 2. This is a gap 3, gap 4, gap 5, gap 6. Now, that no two vowels come together means we have to arrange those 3 vowels in these 6 gaps. Now arrange 3 vowels in 6 gaps. In 6 gaps. Right? It can be done in 6P3 ways. Right? Okay. Which means that first vowel can be placed in any one of the 6 gaps. First vowel can be put in any one of the 6 gaps. Second vowel can be put in remaining 5 gaps. And third vowel can be put in remaining 4 gaps. So 6p3 is nothing but 6 into 5 into 4. So therefore, required number of ways equal to 6p3 into 5 factor. That's equal to 6 into 5 into 4 into 5 factor. I leave the simplification. So whenever that some restricted objects do not come together, first arrange non-restricted objects and then see that how many gaps are there. In those gaps, we have to arrange that restricted objects. It works for any number of restricted objects, whether 2 or 3 or 4 or 5, etc. Well, there is a question from CSAT 2022. Question is quite simple. Once you understand the process, it is a very, very simple question. You can get in 30 seconds also. What is this question? One non-zero digit. So one non-zero digit means you have to take 1 to 9. And one vowel. One vowel means there are 5 vowels. Okay. A, E, I, O, U. And one consonant, there are 21 consonants from English alphabet in capital letters are to be used in forming passwords such that each password has to start with vowel, and end with a consonant, All right. So we have to use one non-zero digit, one vowel, and one consonant. So password consists of only 3 strings, right? So which means that it is the process of filling 3 boxes where the first box must contain vowel, last box should contain consonant, and the middle one must be non-zero digit. Well, so this is the question. The first box must be vowel. So as there are 5 vowels, so we can fill that first box in 5 ways: A, E, I, O, U. And this is a consonant, right? Of course, I don't want to list out all the consonants because there are 21 consonants. Simply, I'll write that this box can be filled in 21 ways. Now, what else is left? Yeah, this is the digit 1 to 9. We have to fill this as a this place from 1 to 9. There are 9 ways. I hope you understand. The first box must be filled with vowel, last one is consonant, and the middle one is a non-zero digit, that is 1 to 9. You can put any one of these 9 digits in the middle place. Well, so therefore required number of ways equal to required number of ways equal to. First place can be filled in 5 ways, that is by vowel. Second place can be filled in 9 ways, that is by non-zero digit. And the third place can be filled in 21 ways, that's equal to 189 into 5. That's equal to 5, 4, 4, 945. So option C is correct. Once you understand the question, without this permutation formulas, we can solve the question just by using the box method. I'll bring another question. Here is another question of CSAT 2022. CSAT 2022. Question seems to be very big, but options contain very small numbers, only 1, 2, 3, 4. So, which means that we don't have much choices to form the rows of given numbers. See, the digits 1 to 9 are arranged in 3 rows in such a way that each row contains 3 digits. And the number formed in the second row is twice the number formed in the first row. Which means that whatever the number written in the first row, we have to write in the second row double of the first number. And the number formed in the third row is thrice the number formed in the first row. Simple. If first number is x, second number is 2x, and third number is 3x. And repetition of digits is not allowed. Repetition of digits is not allowed. If only 3 digits of 4 of 2, 3, 7, and 9 are allowed to use in the first row. Okay. By God's grace, that they have restricted the numbers of first row. We have to use only 2, 3, 7, and 9. How many such combinations are possible to be arranged in the 3 rows? Right? All right. So what is the number of such combinations? Well, second row must be double of the first row. And third row must be triple of the first row. Let us see that. I will write one by one case. Okay. Three rows. And each row contains 3 boxes. All right. Okay. If this is x, this is 2x, and this is 3x. Well, we have to use a 2, 3, 7, 9. Suppose if you take 3, 7, 9, okay, 3, 7, 9. What is 3 times of 3, 7, 9? What is 3, 7, 9 into 3? I will calculate. 3, 7, 9 into 3 equal to, this is 1137. So this case will not work out because every row is a 3-digit number. All right. Like that, you can take 2, 3, 9. What is 239 into 3? 239 into 3 means 1 digit if I take a 9. And here you remember that repetition of digits is not allowed. All 9 boxes should contain different digits. Those are from 1 to 9. Those are from 1 to 9 or 0 to 9. Okay. First, I will take one possible case, that is 3 to 7. I will take that 3 to 7. If I take this case, 3 to 7. So what is 3 to 7 into 2? All right. 3 to 7 into 3. Right? This is equal to, first I will take 3 to 7 into 3. 3 to 7 into 3 equal to 981. 3 times 981. All right. Okay. And what is 3 to 7 into 2? This is equal to 3 to 7 into 2. That's equal to 654. 654. This is 654. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is one possible case. This is one possible case, right? We have to look for, is there any other case is possible? Well, okay. Let us look for another case. First case, we have to do hit and trial. There is no formal procedure in fact. And sometimes we cannot apply that formal procedure in competitive examination. 3 boxes. All right. I'll see that. Here I have listed out all the possible cases of 3-digit numbers formed by 2379. Anyway, first digit cannot be 9. If any number, 3-digit number begin with 9, if you multiply by 2, you will get 4-digit number. We want only 3-digit number. So first digit cannot be 9. Now 9 is eliminated from the first place. Okay. Now the first digit of 3-digit number can be either 2 or 3 or 7. First, I have listed out all the possible cases. Of course, this question is very difficult because in that exam, we cannot list out all these possibilities, but still, this logic can be applied somewhere else. So if you take 237, right, 2, 3, 7, first, according to the increasing order. 237 into 2, we got 474. Here, 4 repeated. Here, no digit being repeated. That is the given restriction. So this case is eliminated. Now 273. I have interchanged these two. 273 into 2, 546, and into 3, 819. So 273. And this is 546. And this is 819. And no digit is repeated. So this case is possible. Now, similarly, if you take 239, okay, because 237 is over, next 239 into 2, 478. Into 3, you will get unit place is a 7. So here 7 is repeated. So this case is eliminated. Next case. Now, remove 3. Now write the numbers with the 279. So 279. 279 into 2, you will get 558. So that's why here 5 and 5 repeated. Therefore, this case is eliminated. Here, if you interchange 3 and 9, you will get 293 into 2, 586. And into 3, you will get unit place is 9. But here 9 is already there. So this case is eliminated. Next, 297. Eliminate, interchange these two. Okay, I have missed a little order here. 297 into 2, 594. Here 9 is repeated twice. Our restriction is no digit being repeated. So therefore, there are two options. There are two options. I'll bring one more question on permutations and combinations. That number of words can be formed using the letters of the word, such that there will be exactly two letters between two letters. This is of 2022 question. This is also very nice question. Does not require any higher level formulas, only basic logic is required. Letters A, B, C, D, E are arranged in such a way that there are exactly two letters between A and E. There are exactly two letters between A and E. How many such arrangements are possible? So I'll just I'll just list out all possible cases and then I will arrange them. You see that A, yeah, here there are two places, and E, this you considered as a single object. This you considered as a single object. And this is the fourth letter. Assume that fifth letter is X. Assume that fifth letter is X, or I'll list out that. Okay. So now we have that B, C, and D. From these three letters, pick two letters and put in these two places. Right. Suppose I'll take B and C. B and C. And here I'll write D. I list out these possible cases. Remember. Now you see, I will arrange that A and E. They did not say that A is the first letter and E is the last letter. So A and E can be arranged in two factorial ways. Two ways. First letter is E and second letter is A. That is, I think, E and A. Okay, I will not take this case. I will not take this case. I'll take that A and E. I'll see once. So here there must be two letters between A and E. They did not specify that A is the first letter and E is the fourth letter. So A and E can be interchanged or can be arranged in two factorial ways. Right? First letter is A and fourth letter is E. Well, now you see. Now B and C can be arranged in two factorial ways. B and C can be arranged in two factorial ways. Well, now these two circles can be arranged. Means first is D, next A, B, C, E can be arranged in two factorial ways. Once again, I'm telling A and E can be arranged in two factorial ways. Simply two ways. B and C, this is case one. This is case one. This is case one. Now B and C can be arranged in two factorial ways, BC or CB. And these two circled letter, these two objects further can be arranged in two factorial ways. First D, next four letters, or first four letters, next D. So for one case, there are 2 factorial into 2 factorial into 2 factorial, that is 8 ways for one case. This is the first case. All right. So there are 8 ways for B comma C. There are 8 ways for B comma C. If the middle of 2 letters of A and E are B comma C. Similarly, this is equal to 8 ways for C and D, and there are 8 ways for A and B and D. All right. Okay. So these middle places B and C can be BC, can be CD, or B and D. So there are totally 3 possible cases. There are totally 3 possible cases. In each case, we have 8 ways. In each case, we have 8 ways. I'll write if you want. Case 2. Same procedure. A, B, D, E. Now outside is C. Right? For this also there are 8 cases. This case, 8. Next, case 3. Case 3. A, C, D, E. This is one object. And outside is A, C, D, E is over. Outside is B. So this is this case. Every case is symmetric. Whatever number of cases obtained in the first case, the same number of cases we can obtain in case number 2 and case number 3. So therefore, required number of ways equal to 8 into 3. That's equal to 24 ways. 24 ways. All right. There is another way also. There is another way. I can apply that method. I will explain in single step. Well, same question. See that A and these 2 places E, and this is the next place. Well, A and E can be arranged in 2 factorial ways. Okay. Now, these 2 places with the remaining 3 letters can be arranged in 3P2 using B, C, D. Out of 3 letters B, C, D, arrange 2 letters here, 3P2. The number of permutations of n dissimilar objects taken or at a time. Here the number of 2-letter permutations between A and E. And this is the third, this is another letter, whatever it may be, like this. Now, these two circles can be arranged in 2 factorial ways. So therefore, total ways equal to 3P2 into 2 factorial into 2 factorial. So 3P2 is nothing but 3 into 2 factorial into 2 factorial into 2 factorial. You will get the same one. That's equal to 24 ways. In the next video, I will explain a few questions of permutations along with when the objects are repeated.